Blessed morning, everyone! Today we're gonna tackle about expanding binomial using binomial theorem. So without any further ado, let's start. The binomial expansion is a formula used to expand a binomial, a two-term expression that is raised to a positive integer. So this is the formula that we're using. N is the exponent, the power you're raising the binomial to, while k is that term of the number starting from 0. The n choose k or nck is the binomial coefficient. Before we go ahead for the examples, there's a one way to expand for binomial theorem, and that is Pascal's triangle. Let's discuss about Pascal's triangle.
Pascal's triangle is a triangular array of numbers that visually represents of the binomial coefficients needed for this expansion. This is the example of a Pascal's triangle. It starts with 1 at the very top, and the next row should be 1 and 1. And after that, every row will end at 1. And the numbers in between are found by adding the two numbers above. So 1 is at the top, the second one is 1, 1. Because it always ends with 1. When you start at 1, so the next one should be 1 on the left and 2 on the middle and 1 again for the right. But how do you get the 2? Okay, first one, you need to add 1, and the other one, that's where you get the 2. Continue that process. On the third row, you will get 1, 3, 3, 1. And the fourth row should be 1, 4, 6, 4, 1. After that, the equation will be x with the sum of 4 plus 4x with the sum of 3 and plus 6x with the sum of 2 and 4x plus 1. Pascal's triangle is very useful for binomial expansion, probability, and even patterns in math. Now let's try to solve the fifth row. Pause this video and try to solve it. And after you're done, unpause this video. Here's the equation. Find for the fifth row, okay? Unpause when you're done. Done solving? Alright, let's move on. After the fourth, you will get this. The fifth row should be 1, 5, and 10, 10, 5, and then 1. And the fifth equation should be x with the sum of 5 plus 5x with the sum of 4 plus 10x with the sum of 3 plus 10x with the sum of 2 and 5x plus 1. If we got that right, congratulations! Let's move on to the binomial expansion solving.
Hello guys, I'm back again. So let's proceed with the binomial expansion using binomial theorem. So that is the given that we're gonna solve. Those are the procedures and the answers, and I'm gonna explain it to you one by one. So now our first term is 3 chose 0 times 3x raised to 3 minus 0 times 2y raised to 0. So if you calculate that, 3 chose 0 is 1 and times 3x cubed and times 1. Why 1? Because if you have 0 exponent, then the answer should be 1. So after that, you will multiply all the numbers. So 1 times 3 times 1 is equals to 3. So the final answer for first term is 3x cubed. So in the second term, 3 chose 1 times 3x raised to 3 minus 1 times 2y raised to 1. If you calculate 3 chose 1, you will get 3. And then times 3x raised to 2 because 3 minus 1 is equals to 2 times 2y. Then after that, you will multiply all the numbers. So 3 times 3 times 2 is equals to 18. So the final answer for second term is 18x squared y. And for the third term, we have 3 chose 2 times 3x raised to 3 minus 2 times 2y squared. So if you multiply that, if you calculate that, 3 chose 2 is equals to 3. Then times 3x raised to 1 times 2y raised to 2. So multiply it, 3 times 3 times 2 is equals to 18. So the final answer for third term is 18x y squared. So for the final and fourth term, we only have 3 chose 3 times 3x raised to 3 minus 3 times 2y raised to 3. If you calculate that, 3 chose 3 is equals to 1 times 1 times 2y raised to 3. So again, multiply it, 1 times 1 times 2 is equals to 2. So the final answer for fourth term is 2y cubed. So if you combine all the answers in each term, you only have 3x cubed plus 18x squared y plus 18x y squared plus 2y cubed. And that's it. Before we end this video, I'd like you to answer this equation and leave your answer in the comment section so that we know that you already understand the lesson. And that's for today. Thank you.